Oh, I was trying a stream um, computer screen, and I had to use a screencast recorder, but it'll do my webcam just fine. I'm just doing this as a test. I wonder if I could do this while it's running. I'm going to turn on this OBS Streamcaster.
You have 15 minutes left of computer time.
Oh, I'm getting kicked off my computer. I have a timer on my computer that knocks me off every 2 hours to take a break, which I don't have the password for. So, and it also tells me to go to bed and also go to work. So, all right. I didn't see it broadcast. It looked like it was trying to broadcast. Let's see. Live streaming. Change some settings here. Anyway, this is my studio right here. I used to use this microphone a lot, but it turns out the mic in my Logitech camera, recommended by Mike Weir at Cam Instructor, this works pretty good. But I used to do my screencast just using this microphone. Only had to install software to get it to work well and record well. I kind of like it though. It looks cool. It looks like I'm a pro. So I still keep it there. But I got dual monitors here, so it's in my way sometimes. I have a Haas classic simulator back there, and hopefully we'll get into some G-code lessons. And I really like using these Haas workbooks right here. This is the older version. I have them printed. The school prints these for me, and everybody gets a copy. We got mill, we got lathe, right? So everybody, this is a great book, by the way. It's got all your basics, should be in your toolbox, all the basics of how G-code works. And why would you want to know G-code? Because most things are produced by CAD/CAM. Is the code correct? Am I making the right selections? If you're a setup guy, how can I adjust things? How can I adjust feed rates or change tool numbers or change heights on the fly? Believe me, I worked in shops for 30 years. You're not going to go running into the programming room to get the guy to change all this stuff. If you're the programmer, yes, but most shops have programmers, setup guys, and then your operations machinists. So you want to know the nuts and bolts of it. As a programmer, you want to know that it's producing the code you intended, especially if you get a new machine like 4-axis lathe or something like that. All these little things are new to you. Are they working correctly? Am I picking the right drill cycle? If I don't even know what the drill cycle is, like a G73 versus a G83. Do I know what's the difference? It might be a description in there. I think we tried it once, and for some reason, it wasn't the G73 wasn't coming out correct. And that also gets in the post-processor editing. So anyway, we'll use these books on basics of writing G-code. Then we always have, these are usually with the machine. And all of these, and I always tell people the biggest section in the book is the G-code section. So if I forget, I can look in here, like these are lathe roughing cycles. And probably the lathe is more commonly used for code writing, 2-axis lathe, than mills, because they're pretty good. You can really write pretty good program in lathe using the roughing cycles and finishing cycles. But they have the same thing here. They give you examples in here. It's quite a bit better. I'm going to get my Mastercam bookmark here. So these are things that I did for years as a machinist. And I did bring in my whiteboard here. I thought I was trying to do digital whiteboarding, but I was trying to describe like, what is a G73 cycle? So it'd be better if I brought it up on
You have 10 minutes
the
left of
screen.
computer
Oh, my
time.
computer's kicking me up again. So let's go into CAN cycles right here. Page is CAN cycle exercises. Deep hole peck drilling. So over here we have G73. This says high speed peck drilling. That sounds cool. Must be better, you know. Is there an example in this book? I am not sure. Is deep hole, is tapping, is bore, more bore, a lot of bore. No, I don't see one in here. Oh, here it is right here. Probably skipped right over a lot, just a little discussion on it. But it's actually got the same pictures that are in the manual. And it's an isometric view, it might be pretty good, but usually if you take an example of the code, this is what I used to do when I worked at shops that had different machines, and sometimes I wouldn't remember, so I'd have a sample of the program. And then a light bulb goes off, I'm like, oh, I remember how that goes. So this is a sample of high speed peck drill using Q. And what's Q mean, right? It's all right there. Q is the pecking equal increment depth. So it's like a woodpecker, only the way this cycle works, it doesn't fully retract. That's why they call it high speed. So it goes down and it breaks the chip, or some might call it chip breaking cycle. I think Fusion calls it chip breaking cycle. And you see it right here. It says setting number 52 or 22. I can't quite read that. So that's a setting that's in the Haas control, the amount of peck. So it's going to go, let's get my whiteboard out. Okay, we got a top here, got a hole, drilled hole. So the amount of peck will be, we're going to call this Z0, right at the top. Down here is Z negative 1.0, right? And we're not going to go, if I did G81, it would go straight to the bottom. Might clog the drill. All right. Let's do it in the G, that would be G81. Right? If I use the G83, which is actually probably the safest pecking cycle, you can now add a Q, and that's be the amount of peck. It'd be like taking a drill press and going down, coming up, going up, coming up. Okay. So you'd be like, okay, I'm going to use a Q value of 0.100, 100 thousandths. We're going to 1 inch, right? It should peck 10 times, but it really it depends on where you're starting from. So normally we're starting like right about here. That would be called the R level. And most people set it at 200 thousandths. Okay, so it actually would be first peck would get just to the top. No big deal. So then the next one would be 100 thousandths, 200, 300, but it's going to fully retract every time. It'll fully retract to the R. And the coolant will splash on it and it'll clean the chip off the tool. Aluminum, copper, those kind of metals that kind of cling to the drill and have long stringy chips. G83, preferred method. G83, safer method. Cast iron, crumbly chips. G83 would work, but G73, which uses the same Q value, right? instead of fully retracting every time, it's just going to go up a little bit by whatever that setting was. So if you say it breaks every 50 thousandths, so it wouldn't have to fully retract all the time. So, but let's say you had to do 100 holes, that would be a time saver. And because it's a crumbly chip, it's not going to clog the drill. Same thing applies to some steels. You could peck drill down and
You
just
have
break the
5
chip.
minutes left of computer time.
All right, looks like I got to get off. My computer's kicking me off here. And it's just my first time I tried a Facebook Live this way, and now I did a YouTube Live. But I want to be able to show somebody something. I had a Mastercam setup over here with Vice and Part, and talking about things you need to look out for, like collision avoidance. Okay, so I'm going to sign off and learning how to do other teaching. And actually, I've been doing online teaching for a little while before the COVID thing. So I really like it. All right, especially in the CAD CAM world or CNC world. All right, thanks. See you later.